Okay, this is a big ball of genius right here. Okay, now, so sometimes, always, never. Can you see the need for a chain rule in some cases? Yeah. Look, now here's the thing. I think I'm learning that this works a lot better. Okay, if you're taking the integral from a constant to a function, and that is just x, then substitute x in and you're done. But if it's more than that, then you still will substitute that in to every place that you see. In this case, it'll be t. T's like the dummy variable. All right. So what you do is you'll just take that g of x and you'll substitute it in. All right. But we took a derivative of it. And so since we're taking the derivative of it, it's just like before. I mean, it is the exact same thing. It is not like a new thing at all. It's the chain rule. All right. So we got to have chain rule g prime of x. She writes that below. A little bit of lag. Not too bad. Okay, now, so that's what we have down here. It's the exact same thing. So we have the derivative with respect to x of an integral, crazy looking stuff here, but it's saying is the derivative and integral are inverse unless you're integrating from a constant to something other than x, and then you need chain rule. That's all there is to it. So they cancel each other out with perhaps a chain rule. And then, man, this is wonderful, all right? Because these are considered really complicated. And so you're just following the first fundamental theorem. We're substituting the g of x in, might need a chain rule. We're substituting the h of x in, you might need a chain rule because you're taking a derivative. All right, so let's do this. All right, example 4. Oh, man, look, we don't need a lot of room. We didn't give us any room at all because we don't need it. So check this out. So f prime of x, big F prime of x is, all right, everywhere you see a t, we're going to put an x squared. I'm not worried about the 0 because that's going to cancel out because it's going to be the derivative of a constant. I don't need that. Anytime there are constants on this upper or lower limit, then you don't have to worry about them, all right, because it's going to be a derivative of a constant. All right, so here we go. So here's the rule. We're going to go e. Everywhere I see a t, I'm going to put whatever that upper limit was, and it's x squared. So I'm just substituting that in. So I've got x squared. Yes, it's x squared squared. Okay. And then guess what? Because we took the derivative, it's a chain rule like always. The derivative of whatever that limit is, because that's the thing that you're going to substitute in, is no longer x. And so the derivative of x squared is 2x. Ain't no way they're going to leave the answer like that. It would probably look like this. 2x, that's your chain rule. That's all it is. Okay, don't be intimidated by that. And then e to the x to the fourth. Done. Done. That's all you got to do. Now, I know that we had to do a whole lot of work to get to the point where we could say that's all you got to do, but that's all you've got to do, and it's been completely explained. All right, so if you ever wonder what in the world's going on with that, go back and watch the previous videos because her work on this is astounding.